The $10 billion James Webb Space Telescope was launched on Christmas morning 2021. The telescope will take a month to get to its place of observation, 1.5 million kilometers from Earth. This is the second Lagrange point, L2. Lagrange points are positions in space where the gravitational pull of two large masses precisely equals the centripetal force required for a small object to move within them. Essentially, objects sent there tend to stay put, and these points in space can be used by spacecraft to reduce fuel consumption needed to remain in position. Now, the first 2 weeks or so on its way to L2 involved an intricate series of steps of unfolding itself ready for work. The telescope had to be folded up origami style to fit into the Ariane 5 rocket that launched it. These unfolding steps, and there were just over 300 of them, have now been finished. About 3 days ago, the last piece of the mirror was finally locked into place. Now, the telescope will take about a month to get to L2, but it won't be ready to use straight away. The 18 mirrors have to be set in perfect alignment, and they each move at about the same rate as a blade of grass grows. So there's 3 months for what's called telescope commissioning. Then add another 3 months for scientific instrument commissioning, essentially getting everything ready. This is all very important to have everything perfect, as the telescope will be too far away for servicing trips. With a primary mirror 3 times the diameter of the primary mirror of the Hubble Space Telescope, the James Webb is 100 times more powerful. It's touted as being the replacement to Hubble, although the two will actually work together. Hubble is great for observing ultraviolet and visible light, but can only detect a small way into the infrared portion of the EM spectrum. James Webb Space Telescope, on the other hand, was designed to primarily observe in the infrared. This is because one of its main goals is to look right back to the earliest stars that formed in the very early universe, about 13.6 billion years ago. The light from these stars is incredibly redshifted into the infrared, hence the need for the James Webb Space Telescope to observe it. Now, speaking of infrared, that's essentially heat, and every object in the universe emits some heat. So the James Webb Telescope actually needs a really cold operational temperature, about 37 Kelvin, which is minus 236 degrees Celsius. This is so that any infrared it emits doesn't actually interfere with the infrared light it's trying to pick up. And that's the reason for the very large diamond-shaped screen underneath the primary mirror. It is essentially a 5-layer heat shield. The heat shield will always be facing the sun, so the telescope's mirror and instruments can be kept nice and cool. Now, not only will the James Webb Space Telescope be looking at light from the very first stars, it will also be able to see stars hidden in nebulae, as well as analyze the atmospheres of extrasolar planets for signs of chemical signatures of life. So yeah, the next 10 years, the lifetime of the James Webb Space Telescope, are sure to be amazing. But wait, just 10 years? Yeah, that's the limit of the fuel in terms of keeping it where it should be. Unlike the Hubble Space Telescope, which has been operating for 31 years and could keep going up until 2040. However, also unlike Hubble, the James Webb Space Telescope is too far out for servicing. Remember, 1.5 million kilometers away. That's nearly 4 times the distance to the moon. So if something does go wrong, NASA won't be able to send astronauts on a fix-it mission, as has happened with Hubble. Still, we get 10 years with the James Webb Space Telescope, and in that time, it's sure to prove its worth time and time again.
Hey you, hit the like button. Yeah, and the subscribe one too. Yay!